So, two-step equations. So this is when we have more than one thing to do in order to get the variable by itself. So what I'm going to tell you first is, and we talked about this in chapter 1, when you simplify something, what order do you go in? When you simplify an expression, we did a whole section on it. Yes, the PEMDAS, right? We use PEMDAS. So when we solve is the opposite of simplify. So we want to go backwards PEMDAS, okay? So when we solve, I'm going to call it SADMAP. SADMAP, okay? So what we're doing is this time, instead of going forwards with the order of operations, we're going to go backwards with it. So parentheses are last, okay? I'm looking for anything that's added or subtracted to the variable first, then anything that's multiplied or divided, then any exponents followed by parentheses, okay? And if you follow this, you'll be able to solve any equation. We're still going to use our opposite operations we talked about yesterday. And we're still going to isolate the variable, but this time there might be more than one thing being done to the variable. For example, maybe I have 5x plus 9 equals 24. So my question to you is, how do I know what to do first? I know I need to get this x by itself. Okay? But there's two things happening to x. What two things are happening to x? Yes, they multiplied by 5 and added 9 to it. So the question is, how do I know which one to get rid of first?
The addition.
The addition. Why?
No, because it's first.
It comes first. I'm backwards now. So the first thing I do is I look whenever I'm solving is I say, okay, do I have any addition subtraction outside of parentheses? And you're not going to have in parentheses just yet, but you will. So it's a good thing to keep it in mind that parentheses come last. All right, so yes, I have addition or subtraction, right? I have this big 9 here, so how do I get rid of the 9?
Subtract the 9 on both sides.
Subtract the 9 on both sides. Okay? Guys, I need y'all to focus. So the 9s are now gone, and I have 5x. What's 24 minus 9? 15. Okay? So now yeah. Okay, what's the next part? You divide it by 5, exactly. Now it looks like what we did yesterday, but I'm moving on to the multiplication division. So Aiden, you're absolutely right. I divide by 5. X equals 3, yeah. What do you mean what numbers you put on the bottom? Well, it has to be this same number. Because it's stop, Ramon. Because it's got to cancel out. We're trying to cancel out. That's why. All right. Let's check it, shall we?
No.
Yes, we shall. 5. Instead of x, I'm going to put a 3 plus 9. Now this way is PEMDAS because I'm simplifying. Okay? So you've got to remember, simplify, PEMDAS, solve, SADMAP.
Okay,
all
so
right.
do we need to check on our homework? Like, do we check? Like, do we have to check?
Doesn't matter.
Okay.
What's 5 times, or what do I do first?
5 times 3.
You get 5 times 3, which is 15. And 15 plus 9 is 24. So does 24 equal 24? Yes, it checks. I have the right answer. I'm good to go. Okay? We just got to go backwards in that order of operations whenever we solve.
Everyone see? You're not true. Like, we're inside.
Let's do another. Let's do 4y, I'm going to change your variable up a little bit, minus 4 equals 16.
Minus 4 on both sides and do 4 divided by 16.
Plus, we do
Okay,
the
plus
subtraction,
4.
so we plus 4, because right now it's being subtracted. So in order to cancel that out, Jordan, you're writing this down, right? You need to put that away. We're going to add 4 to both sides. This one's canceled. I have 4y equals, somebody tell me, 20.
Equals 5.
Good job.
Yes.
Now I move to the multiplication division, which means I divide by the 4, and I have y equals.
This is so easy.
You think so?
Yes, or G.
Let's check it and make sure. Because we need to make sure we have the right answer. We don't want to lose points on our test, right?
Oh, yes, I'm definitely checking on my test.
4 times 5 minus 4 equals 16. What do I do first? The multiplication. You're right. Don't get confused because when we're solving, we're backwards. When we're simplifying, we're PEMDAS. All right, so 20 minus 4. What is 20 minus 4? 16. Does 16 equal 16?
Yes.
Yes. I got to show you a couple more things. I want to make sure I show you every scenario here. How about this one?
Go, Tiana. You know I always said Monday through Friday.
X over 2 plus 5 equals 11. Stay with me, guys. Stay with me.
It's 10:30.
What do I do first? The addition. So how do I get rid of addition? Subtraction. So what am I subtracting from both sides? 5.
Wait, that's 11, right? Okay. Me too.
Okay, so that's when I'm multiplying x by a fraction. In this case, I'm just dividing x.
It's 6. Oh, it's 12.
All right, so I got x over 2, and y'all said 11 minus 5 is 6. So now the question is, how do I get rid of that 2 that's under x? You multiply, because if it's under x like that, that means x is being divided, and the opposite of dividing is multiplying.
Wait.
All right, let me ask you this. Have you ever heard of something called
Yes, ma'am, we did.
like terms?
Yes, ma'am.
What does it mean, guys? Stay with me. I told you I had one more thing to do. What does it mean to be like terms?
We didn't check it.
What numbers are the same? What's the same? What's it mean to be? All right, like terms means that they have, when we talk about terms, I'm talking about algebraic terms, so things like 2x, okay? 2x and 5x are like terms.
Oh, because we got to go X.
7 and 2 are like terms. Because they don't have a variable, they're both constants. Okay. 6x squared and negative 3x squared are both like terms. So like terms means they have the same variable if they have a variable. Constants don't have to, with the same exponent. Okay. Now I don't see an exponent on that 2x and 5x. What does that mean? Does it have an exponent?
Yeah.
Everything has an exponent. What's the exponent if you don't see one? What about it? I can raise anything to the what power and it stays the same? The first power. There's an imaginary 1 as an exponent. So these are like terms, okay? Now we'll talk a lot about like terms later and we'll get to ones that have bigger exponents. But for right now, I want you to think about ones like this and like this. Now, you know how, if I put a plus here, you know how to add those, right? It would just give you 9. But what if there's an x there? What if I wanted to say 2x plus 5x?
You will have to do
7x.
7.
You're exactly right. So when you have like terms, okay, what you do, and let me put this over here, to combine like terms. I'm on pen. No, you're not. No, you're not. We're going to take it slow. Come on, pen.
You about to write super like that?
To combine like terms. Yes, if my pen will work with me here. Please, pen, please.
Oh, God, oh, Mom.
Please.
Pretty outside chilling.
To combine like terms. Still construction workers. All you do is combine the numbers in front. Does anybody know what those numbers in front are called?
You're going to say it and I'm going to say it.
Coefficients.
Oh, yeah.
Coefficients.
Oh, yeah, I heard that before.
So we leave the variable alone, but we combine the numbers in front when we combine like terms. So, Miss McGee, why are you telling me all this about like terms?
Man, Jordan, that. No, it was how I was.
Okay? Let's say we have something that looks like this. Okay? So I have an equation with more than 1x. Okay? Before I solve it, I have to combine like terms. Okay? Then I can solve it. So my first step is to combine like terms.
7 is 4x.
And then my next step is to actually solve it. So I'm going to give you a second to copy that down before I work it. All right. When I combine like terms here, because I see more than one x, what is 7x minus 4x? Somebody said it. 3x. Because I want to do 7 and negative 4, but I want to keep the x on it. Well, now it's a one-step equation. It's not even a two-step equation anymore, okay? Now be very careful, because this is not 7x minus 4 equals 21, it's 7x minus 4x equals 21. So you have to be able to recognize that this one's got two x's in it, okay? Don't just go solving it sad math to start with before it's simplified. Now what do you do? Solve it. How do I solve it? What do you do? Divided by. What does x equal?
X equals
7. Okay? When I check it, I want to go back to that original equation, because if it doesn't work, I could have made a mistake in combining my like terms or somewhere else. So I always want to go back to before I did any manipulation to it at all. So let's check it. Seven times 7 minus 4 times 7 equals 21. As I check this, am I going PEMDAS or am I going SADMAT? PEMDAS, because I'm simplifying. Okay, checking, I want to go PEMDAS. So, no parentheses, no exponents. How about the multiplication division? Yes, there's multiplication. What's 7 times 7?
49.
What's 4 times 7?
28.
The question is, does that equal 21?
Yes.
Yes, it does. So, yes, that's the answer.
My notes on it is so beautiful.
Good. That'll be very helpful as you prepare for the
All
test.
of mine's still on the first page.
All right, let's do one more example, then I'll set you loose.
See, look at it. Say something.
All right, here we go. Try this one on your own first. Then let's do it together. All right, let's do it. I see two variables in here, and my question is, are they like terms?
Yes. Yeah.
What is 5b minus 7b? Now how do I get b by itself?
You divide by 2. And divide by
So I have 5
So I don't
Yeah.